Hello to all participants. My name is Olga Harkava. I am from National University Yuri Kondratyuk, Poltava Polytechnic. I am presenting the report on topic bearing capacity of biaxially bended beams based on the design strengths of reinforced concrete. The concept of the design strengths of reinforced concrete and its application were considered for members subjected to plane bending. The essence of the considered approach is that reinforced concrete is reflected as composite that has a certain strength characteristic, the design strength of reinforced concrete, FZM. At the same time, the strength problems of such members are solved on the basis of classical theory of resistance of materials. The implemented characteristic FZM is an integral value that takes into account the strength characteristics of concrete and reinforcement, the amount of reinforcement in the section and its location. Values, the design strengths of reinforced concrete, are tabulated for different classes of concrete and reinforcement and different reinforcement ratios. Complex deformation of reinforced concrete members is widespread in the practice of operation of many building structures, wherein it may be caused by both force and random factors of constructive, technological, and operational nature. In general, it proposed to solve the strength problem of such members using the design strengths of reinforced concrete on the basis of presented dependence, where FZM is the design strength of reinforced concrete member at plane bending, and the coefficient gamma is a reducing coefficient for the design of strength of reinforced concrete at biaxial bending. To determine the coefficient gamma, it is first considered the case of biaxial bending of a reinforced concrete beam in which the compressed concrete area has the form of trapezoid. Obtaining the design strengths of reinforced concrete bending of reinforced concrete at biaxial bending is considered for members of rectangular cross-section with single reinforcement. At the same time, the assumptions for design according to Eurocode 2 are used. In particular, a rectangular stress distribution in the concrete of compressed area is taken into account, and also bilinear diagram of the stress-strain dependence for tensile reinforcement. The deformation criteria is used as a destructive criteria on the basis of adopted assumptions. The coefficient of reduction, the design strength of reinforced concrete at biaxial bending for rectangular cross-section with trapezoidal form of compressed area is derived in the presented form from equations of equilibrium. To obtain the dependence for angle of natural axis inclination angle theta, here, the condition of parallelism for the planes of internal and external bending moments action is applied. Having singled out the ratio of geometrical characteristics of the cross-section as one that may be specified, the formula for determining angle theta is written on the slide. In the similar way, the dependencies for the triangular form of compressed concrete area are found. It's coefficient gamma and the angle theta. Full calculation of biaxially banded members according to described method is possible only if the form of compressed concrete area is known. For its definition, the prerequisite is adopted on the transformation of trapezoidal form of the compressed area into triangular on the border of limiting state of its existence. Based on the condition, the condition of delimiting the forms of compressed area is obtained and is shown here. Using all derived dependencies, it's possible to determine the coefficient gamma of reducing the design strength of reinforced concrete at biaxial bending, depending on the angle of inclination of external load plane. At the same time, the ratio of geometrical characteristics of the section and also longitudinal reinforcement ratio are also taken into account. For the example, the values of such coefficient gamma for members with reinforcement of class A400C are given in the table in the range of angle beta from 0 to 14 degrees. Using the developed method, the bearing capacity of biaxially banded beams was determined. The calculation results and experimental data are shown at the next slide. Their comparison evidences that the proposed method ensures a satisfactory convergence of theoretical and experimental data. From conducted research, it is concluded that bearing capacity of biaxially banded beams may be simply determined based on the design strength of reinforced concrete. Thank you for your attention.